Welcome back, everyone, to the deep dive. Ready to get visual?
Always.
Today, we're tackling something that might sound a little, I don't know, abstract, visualizing problems in programming. But trust me, this is going to be super practical no
Yeah.
matter what your skill level is. We're diving deep into a blog post from Algo Academy
Oh, nice.
called, get this, 55 Powerful Techniques for Visualizing Problems to Find Solutions in Programming.
55. That's a lot.
It is, right? But don't worry, we're not going to cover all of them today. Just
Yeah.
the most impactful ones. This deep dive is perfect whether you're prepping for like a technical interview
Yes.
or just want to get better at problem solving in general.
Absolutely.
So let's jump right in. Let's start with some techniques you're probably already familiar with, things you've used in other contexts, but maybe not thought about applying to coding.
Okay, sounds good.
First up, mind mapping.
Classic.
Right. But most people associate mind maps with brainstorming, right? So how can we actually use them for coding problems?
Well, it's all about seeing the big picture. Let's say you have, this complex coding challenge you're facing. You put the problem right at the center of your mind map, and you start branching out with ideas.
Oh, I see. So it's kind of like creating a visual roadmap for your code before you even write any code.
Exactly. It helps you, organize your thoughts and see the connections between different parts of the problem.
So you don't get lost in the weeds.
Right. Especially when things start to get complicated.
That makes total sense. Okay, now how about flowcharts? I remember those from my intro to computer science days.
Oh, yeah. Flowcharts.
Yeah.
They're great for clarity. They show you the steps of an algorithm, which can really help you understand, the flow of your code.
Like a blueprint.
Yeah, exactly. You can see the different paths your code might take based on, decisions or conditions.
And you can use, standard symbols, too, right? Like diamonds for decisions and rectangles for processes. It's like a visual language for algorithms.
Absolutely.
Okay, so we've got mind maps for seeing the big picture, flowcharts for mapping out the logic. What about Venn diagrams?
Venn diagrams.
Yeah, they always make me think of set theory from, math class.
Uh-huh. Yeah, I get that. But they can be super useful for programming, too. Imagine you're comparing different algorithms. You could use a Venn diagram to visualize the trade-offs between them, their time complexity versus their space complexity.
Oh, so if one algorithm is really fast but uses a lot of memory and another is slower but more memory efficient, you could show that visually with a Venn diagram.
Precisely. It helps you weigh the pros and cons of different approaches and pick the best one for what you're trying to do.
That's super helpful. Okay, so those are some familiar techniques, but now let's get into some techniques that are more specific to coding, okay? Things that are really designed for visualizing code and data. What about data structure diagrams? Have you ever used those?
All the time.
Really? I've seen them, but to be honest, I haven't really used them in my own work. Tell me more about how they can actually help you write better code.
Okay, so imagine you're working with a, complex data structure, like a tree, a graph, or a linked list.
Yeah.
If you sketch out a visual representation of that data structure, it can make the relationships between the elements so much clearer.
So instead of just picturing a tree in my head, I could actually draw it out with all the nodes and branches.
Exactly. And that visual can help you see how, different operations will affect the data structure. It's almost like having X-ray vision into your code.
I love that, X-ray vision. Okay, now what about those situations where you have a problem that has different states, like a user interface or a game? Those can get kind of tricky to manage, right?
Oh, for sure. And that's where state diagrams come in. They're kind of like flowcharts, but specifically for states.
Oh, okay.
You map out each state and the transitions between them, so you can see how your program will behave under different conditions.
So I could use a state diagram to show what happens when a user clicks a button, or how the game changes based on player actions.
Exactly. It gives you a clear view of the different possibilities. Super helpful for both designing and debugging.
That makes sense. Okay, last one for this section, UML diagrams. I've heard of those, but I'll admit I'm not totally sure what they're all about.
So UML stands for Unified Modeling Language, right?
Yeah.
And it's a standardized way to visualize different aspects of a software system. They're really helpful for team communication because they give everyone a shared language for talking about the code.
So it's like a blueprint for your whole software project.
Exactly. There are all sorts of UML diagrams, like class diagrams, which show the relationships between different classes in your code, and sequence diagrams, which show how objects interact with each other.
Okay, that's a lot of information, but I'm starting to see how all these techniques can be super helpful. I guess the question is, why is visualization so important in programming? Couldn't we just, write code without all these diagrams? It seems like a lot of extra work.
Well, here's the thing. Visualization is crucial because it helps us with three things: understanding, debugging, and communication. When we can see something visually, it's just so much easier to grasp. And when it comes to debugging, visualizing your code can help you pinpoint errors more quickly. And finally, it's all about communication. Visualization tools allow us to share our ideas and solutions with others in a way that's just like crystal clear.
So it's not about making things look pretty. It's about making things easier to understand, easier to debug, and easier to communicate.
Exactly. It's about using visual tools to think better, to solve problems more effectively, and to collaborate more seamlessly.
I love that. Okay, so the Algo Academy blog post also talks about pseudocode as a visualizations technique. What's that all about?
So pseudocode is basically a way to express the logic of an algorithm without getting bogged down in, like, the specific syntax of a programming language. It's like a rough sketch of your code, but in a way that's easy for humans to read.
Oh, okay. So instead of writing actual code, I could use pseudocode to like outline the steps in plain English.
Exactly. And the blog post gives a really cool example using a sorting algorithm. It shows how you can break down the steps in a visual way using pseudocode.
I can see how that would be super helpful, especially when you're first starting to design an algorithm.
Absolutely. It helps to clarify your thinking and, make the whole problem-solving process more intuitive.
That's awesome. So we've covered like mind maps, flowcharts, data structure diagrams, UML diagrams. We've even touched on pseudocode. It's amazing how many different visualization techniques there are.
And we've only just begun. There are even more specialized techniques out there.
Wait, really? Like what?
Well, there are things like heat maps, force-directed graphs, even flame graphs.
Ooh, I'm intrigued.
They might sound a little intimidating, but trust me, they can be super powerful tools for understanding complex programming problems. But we'll save those for the next part of our deep dive.
Okay, I'm on the edge of my seat. I can't wait to hear more about those in part 2. This has already been so insightful. I'm really excited to keep uncovering these visual treasures.
Yeah, me too. It's going to be fun. Welcome back. Ready for more visualization awesomeness?
Oh, absolutely. That last section was mind-blowing. I never realized how much visualization could actually help with, like, understanding and solving coding problems.
Right, like a whole new way of thinking about code. And today, we're going to dive into some even more specialized techniques, stuff that can help you tackle those really tricky challenges.
Okay, bring it on.
All right, so let's start with a technique you might recognize from project management: Gantt charts.
Gantt charts. Wait, aren't those for, like, scheduling and timelines?
Yeah, exactly. But you can actually use them for programming too. It's all about visualizing, like, the sequence and dependencies of different parts of your code.
I'm not sure I'm following. Can you give me an example?
Okay, so think of each task on a Gantt chart as a step or function in your code. You can map out the order of operations, see which parts can be done in parallel, and even identify potential bottlenecks.
So instead of just thinking about the steps linearly, I can use a Gantt chart to see, like, how they might overlap or depend on each other.
Exactly. It can be super helpful for understanding those complex algorithms and figuring out how to optimize them.
That's cool. Okay, what else do we have?
How about storyboarding? Like in filmmaking.
Storyboarding. Wait, are we talking about drawing out scenes for a movie? What does that have to do with programming?
Well, it's about visualizing the flow of events or actions. So let's say you're building a user interface or a game.
Okay.
You could use storyboarding to sketch out the different screens or scenes and how the user interacts with them.
Oh, I see. So it's like a visual representation of the user's journey through my app.
Exactly. You can map out what happens when they click a button, navigate to a different screen, all that stuff.
That's a really neat way to think about it. It's like making sure the user has a smooth and intuitive experience.
Right. Now, how about concept maps?
Concept maps. I've seen them, but I haven't really used them myself. How do they fit into the programming world?
Concept maps are all about visualizing the relationships between, well, concepts. You can use them to map out the components of your system, see how they interact, and even spot areas where your understanding might be a little fuzzy.
Oh, so I could use a concept map to represent, like, the different classes in my code and how they relate to each other, or maybe the modules in a big project.
Exactly. It helps you see the bigger picture and understand how all the pieces fit together. And speaking of bigger pictures, when you're dealing with hierarchical data, tree maps are super valuable.
Tree maps, those are the rectangular diagrams with all the smaller rectangles nested inside, right?
You got it. They're a great way to visualize hierarchical data, like file systems or even, the structure of a complex data structure.
Yeah.
The size of each rectangle represents a value. like the size of a file or the number of items in a category.
So I could use a tree map to see the directory structure of my project, with the biggest rectangles representing the folders with the most files.
Exactly. You can instantly see what's taking up the most space. Okay, now remember those force-directed graphs we talked about earlier?
Yeah, I'm still curious about those.
Okay, so a force-directed graph is basically a visual representation of a network. Think of it like a social network, where each person is a node, and the connections between them are edges.
Okay, so it's like a map showing who's connected to whom.
Right. Now imagine applying that to your code. You could use a force-directed graph to see the dependencies between modules in the large project.
Oh, that's cool. So each module would be a node, and the connections would show if one module needs to use code from another one.
Exactly. It can help you see the structure of a complex code base and spot potential issues. Now, have you ever heard of Sankey diagrams?
Sankey diagrams? Nope, that one's new to me. What are they?
Imagine a diagram with like flowing ribbons, where the width of each ribbon represents the amount of something flowing through it.
Oh, okay. So I could use a Sankey diagram to visualize how data moves through my application.
Exactly. It shows you the flow of data from one component to another and how much data is being processed at each stage.
That's a great way to see the big picture of data flow. And speaking of big pictures, how about this one? Ishikawa diagrams, or sometimes they're called fishbone diagrams. Fishbone diagrams, that's a new one.
So picture a fish skeleton, all right? The head of the fish is the problem you're trying to solve, and the bones branching out represent the different potential causes of that problem.
Oh, that's a really cool way to visualize it. So it's like a brainstorming tool for figuring out what's causing a bug or a performance issue.
Exactly. It helps you break down a complex problem into smaller, more manageable pieces. Now, remember those heat maps we talked about?
Yeah, the colorful grids. I'm still curious about how those can help me with coding.
Okay, so imagine a heat map that shows you the code coverage of your tests. The hotter the color, the more thoroughly that part of your code has been tested.
Oh, that's smart. So it's like a visual representation of my test suite.
Exactly. You can quickly see which areas need more testing. Or you could use a heat map to visualize how often different functions are called, with the hottest areas representing the most frequently executed code.
I love that. It's like a thermal image of your code. You can see where all the action is happening.
Right. And finally, let's talk about radar charts, also known as spider charts. They're great for comparing multiple things visually.
Radar charts, those are the circular ones with the spokes, right?
Yeah, exactly. So let's say you want to compare different algorithms based on things like speed, memory usage, and ease of implementation. Each spoke represents a different factor, and the shape of the resulting web shows you at a glance which algorithm is the best overall or in specific areas.
That's so clever. It's like a visual scorecard for your algorithms.
Exactly. And that's the beauty of visualization. It gives you these powerful tools to make sense of complex information.
This is incredible. It's like a whole new world of visual tools has opened up to me.
And we're not done yet. There are still more amazing techniques to explore.
I can't wait. This is like a treasure hunt for visual insight.
It is. But I think we need to take a break for now and let all this awesomeness sink in. We'll be back soon with the final part of our deep dive.
All right, we're back for the final part of our deep dive into visualization techniques. I'm ready to see what other visual treasures are waiting for us.
We got some good ones. You ready to jump back in?
Absolutely. Let's do it.
All right. Let's start with something that's, fundamental for understanding networks and graphs. Network diagrams.
Network diagrams. Oh, yeah, I've seen those before with all the interconnected nodes and edges and stuff. But how do we use those in programming? It's not like we're drawing out, maps of the internet.
No, not quite. But the idea is similar. Think of anything that involves connections or relationships, right? Like social networks, transportation systems, even dependencies between modules in a big software project. A network diagram can show those connections visually.
So if I'm working on a project with tons of modules that rely on each other, I could use a network diagram to see those dependencies and how changes in one module might affect others.
Exactly. It's like a map of your project's structure, you
Yeah.
know. And it can help you spot potential trouble spots, like those circular dependencies that can really mess things up. And speaking of structures, when you're working with hierarchical data, tree diagrams are super useful.
Oh, yeah, tree diagrams. I've seen those for family trees, organizational charts, even decision trees.
Right, exactly. In programming, tree diagrams are perfect for showing things like binary search trees, file system hierarchies, or the structure of a complex data structure. You can see those parent-child relationships, the levels of the hierarchy, even the order that elements are accessed in.
So, like, if I'm working with a binary search tree, I could draw a tree diagram to see the nodes and the branches and how it's all organized.
Exactly. It can really help you understand how search operations work and how the different nodes are connected. Okay, now let's talk about visualizing, the operations of basic data structures, like stacks and queues. Remember those?
Oh, yeah, stacks and queues, they're all about the order of elements, right? Like, a stack is like a stack of plates where you can only add or remove from the top.
That's a perfect analogy. And visualizing how elements are added and removed can really help you understand how they work and, how to use them in your code.
Man, I wish I had known about visualization when I was first learning about stacks and queues. It would have made things so much clearer.
It's never too late to embrace visual thinking. And speaking of clarity, let's talk about memory diagrams.
Memory diagrams.
Yeah, they can help you understand, like how data is stored in memory,
Hmm.
how variables are stored, how pointers work, all that stuff.
So it's like seeing inside the computer's memory, right? Like where everything is and how it's all connected.
Exactly. And that can be super helpful for debugging, memory errors and understanding how your code interacts with the actual hardware. Now, how about recursive algorithms? Those can be tough to wrap your head around.
Oh, yeah, recursion can be super confusing, even with like a ton of comments in the code.
Totally. Well, a recursion tree can be super helpful for visualizing the process. It shows you that branching structure of the recursive calls, making it easier to see how the algorithm breaks the problem down into those smaller pieces.
Oh, okay. So instead of trying to figure out all those nested function calls in my head, I could draw a recursion tree and actually see how the problem is being solved step by step.
Exactly. It's a great way to, demystify recursion. Now, let's talk about something that might sound a bit more specialized. Voronoi diagrams. Ever heard of those?
Voronoi diagrams? Nope, that's a new one for me.
Okay, so imagine you have a bunch of points scattered on a plane, right? A Voronoi diagram divides that plane into regions, where each region contains all the points that are closer to one specific point than to any other.
Oh, okay. So it's like a map of proximity showing which areas are closest to each point. But how does that relate to programming?
It's got applications in, like nearest neighbor searches, spatial partitioning in game development, even visualizing clustering algorithms. It's really useful for understanding spatial relationships. Now, when it comes to image processing or grid-based problems, pixel matrix visualizations are perfect.
Pixel matrix visualization. So like visualizing images as grids of pixels.
Exactly. Each cell represents a pixel, and you can use color to show different values or states. It's a great way to visualize image processing algorithms, cellular automata, anything that can be mapped onto a 2D grid.
Oh, that's cool. It's like you're zoomed in on an image and you can see how each individual pixel is being manipulated.
Exactly. Now, sometimes a static visualization just isn't enough, right? For complex algorithms or dynamic processes, animated visualizations can be super helpful.
Animated visualizations. That sounds awesome. It's like turning your code into a movie.
Right. And there's some amazing tools for creating these, like
Yeah.
D3JS, for web visualizations, or Python libraries like Matplotlib. You can watch your algorithms unfold over time, see how data structures change, even interact with the visualizations to explore different scenarios.
Wow, that's incredible. It's like having a simulator for your code. Okay, so we've covered so much here. Is there anything else we should explore before we wrap things up?
There are tons of visualization techniques out there, and we've really only scratched the surface.
Right.
But I think we've covered a good range of tools that can be super valuable for any programmer.
This has been amazing. I feel like I have a whole new set of tools for understanding and solving problems. What's like the one piece of advice you would give to listeners who are excited to start using visualization?
Just experiment. Try different techniques. Play around with different tools. See what clicks for you. It's a skill that you build over time, so the more you practice, the easier it gets.
Mm-hmm.
And the best visualization is the one that helps you, understand the problem, find the solution, and communicate your ideas effectively.
Awesome advice. Well, if our listeners want to learn about all 55 techniques in that Algo Academy blog post, where can they find it?
It's a great resource. Just search for Algo Academy Blog 55 Powerful Techniques, and it should pop right up.
Perfect. Well, this has been a truly eye-opening deep dive. Thank you so much for sharing all your knowledge with us.
My pleasure.
And to all our listeners, keep coding, keep visualizing, and we'll see you next time on The Deep Dive.